Hi guys, in this video I'm going to run through how to answer all of the questions that appeared in Maths Paper 1 of the Year 6 SATs 2024. Okay, so question 1 is a really simple addition question. It's simply about adding up using the formal written method for addition. So the most important thing is that you are lining up your digits correctly, making sure that your 38, your 3 10s and your 8 1s are underneath the 8 10s and 9 1s, and then just adding them up. This really is just about showing that you know the formal written method of addition. So 9 plus 8, 17, 8 plus 3 plus 1 is 12, and 6 plus 1 is 7. The main thing here is to make sure that your 2-digit number is lined up correctly underneath your 3-digit number. Here we have a simple short division. We need to make sure that we use the formal written method of short division. So we are going to use the bus stop method. We've written our 72 inside the bus stop. We write our divisor outside. 3 into 7s go twice. There is a remainder of 1. And 3 into 12 goes 4 times. The answer is 24. Some of you may be using the formal method of long division to solve this short division problem. So you may be using doing 3 into 7 goes twice, 3 times 2 is 6, 7 take away 6 is 1, and then bringing the 2 down, and 3 into 12 is 4, and we prove it. 3 times 4 is 12, take that away, that's 0, and that's your answer. This, however, is long division. It still gets the same answer. This is the formal method of short division. Here we have a short multiplication question. We need to make sure we line up our digits correctly and then show that we know how to solve the problem. So 3 times 6 is 18, 2 times 6 is 12, plus your 1 is 13. Your answer is 138. It's simply a short multiplication problem. Here we have a subtraction problem, and we are just using the formal method of subtraction. We need to make sure that we line up our digits in the correct columns. So my 110 goes under the 3 10s, and my 9 1s goes under the 2 1s. You are simply showing that you understand how to carry out this formal written method. So 2 subtract 9 we can't do. 12 take away 9 is 3, 2 take away 1 is 1, 5 take away nothing is 5, 4 take away nothing is 4. You're just showing that you understand how to do the formal written method of subtraction. Here we have another short multiplication. We have our larger number second, but we still put it first. So when we are doing our formal written method, we put our 3-digit number first, followed by our 1-digit number. And then we can carry out the problem. 1 times 3 is 3, 9 times 3 is 27, 3 times 3 is 9, plus the 2 is 11. So it's the formal written method of short multiplication, making sure that you put your larger number first. Okay, so for this question, the main thing we need to realise is that just because the answer box is on the left hand side of the equal sign does not make it any different than if it was on the right hand side. Often this throws us. We're used to seeing a question with an equal sign then on the right side of the question, but an equal sign just means that both sides share the same value. So actually, if you were just to rewrite this question as 9171 subtract 53 equals, it would be a lot less intimidating to many of you. You would then be able to see, that's what I need to do. And it's just a really simple subtraction. So just going to use the column subtraction method, remembering to line up our digits correctly so that the ones are over the ones, the tens are over the tens, etc. And we can just start to subtract it. We know we can't subtract 1 from 3, so we are just going to do some exchanging and regrouping. 6 take away 5 is 1, 1 take away nothing is still 1, 9 take away nothing is still 9. And that would be our answer. Our answer is that 9,118 is the same as, that's what equal means, is the same as 9,171 take away 53. There are a few questions like that in this SATS 2024 arithmetic paper, where we have the answer on the left hand side of the equal sign. Just switch it round if it helps you to visualise that it's just a simple subtraction sentence. It's just that the answer is written on the left instead of on the right, and it's as simple as that. Here we have a short division problem. We're going to put the number that we're dividing inside a bus stop, and the number we're dividing by outside the bus stop, and we're just going to divide. 6 goes into 6 once, 6 goes into 6 once, 6 goes into 0 no times, 6 goes into 0 no times, and there's our answer, 1,100. So for this question we have three numbers, 99 times 10 times 1. Anytime you are multiplying three numbers, you can multiply two of those numbers together first, and then you're left with just two. So for example, in this one, I would look at the two that are easiest to do. So I would just do that, and I would swap that 10 times 1 for a 10. So all I need to do now is 99 times 10. So I've just changed the 99 times 10 times 1 to 99 times 10, because this 10 represents these two numbers subtracted together. And when you're multiplying something by 10, you don't need to do long-winded long multiplication methods. You should know that multiplying by 10, you simply increase the value of each of these digits by 10, which means they move to the left. So my 9 tens becomes 9 hundreds, my 9 ones becomes 9 tens, and then I need a placeholder. So 99 times 10 is 990. And it doesn't matter what way round you do this. You could have chosen two different numbers, could have chosen to multiply, for example, the 99 and the 1 together. Well, that would have just given you 99 times 10 still, so you still will be left with 99 times 10. Or you could have multiplied the 99 times 10 to make 990 and then times that by 1. Either way, doesn't matter what two of the numbers from the three you multiply together first, you will always end up with the correct final answer. It's just easiest to do it like that. This question is a very simple addition question. Where there are lots of errors made are when we don't line the digits up correctly. So how I like to do problems like this is I like to write the largest number on top. If it's addition, you can change the order. Obviously, if it's subtraction, you cannot change the order. But I would write the biggest number on top. It's not, however, necessary. It's just my preference. And you just need to make sure that you separate each digit. Now, the decimal point, you might want to put it in its own square, or you might want to put it in the corner. Just make sure you are consistent. I'm going to put this in the corner here. And you do also need to make sure that when you write your decimals, that they don't look like commas. That does actually get penalised sometimes in the SATs. Now, it's a bit harder for me to write the decimal point using a sort of computer pen, but I'll give that a go. So 13.493 add 7. Now don't accidentally put your 7 here. This is what we see happen. Okay, that would be incorrect. We need to make sure that they are lined up in the correct places. So my 7 is 7 ones. That's going to go under the 3 from 13. 3 ones, 7 ones. My decimal point is going to go in exactly the same spot. And then my 6 tenths, my 8 hundredths. Now, what I like to also do when I have two numbers where they have different decimal places is I just fill in any gaps with zeros. So that does not alter the number. 7.680 is not different than 7.68. It's just unnecessary to write it, so we write it as 7.68. But I always put that there. It just helps when you're adding to avoid making errors, especially when you are subtracting. So I'm just going to write my answer in a different colour. Now you just start adding. 3 plus 0 is 3. 9 plus 8 is 17. We're going to carry our 1. 4 and 6 is 10, plus the 1 is 11. We're going to carry our 1. You need to make sure you put your decimal point in the same place that the other decimal points are. 3 plus 7 is 10, plus 1 is 11. Carry the 1. 1 plus 1 is 2. And there you have your final answer. The most important thing is to make sure that every digit is lined up in the correct place, either above or below another digit of the same value. Here we have another short multiplication problem, and again our larger number is second. We just need to remember to pop that larger number first. We pop it on top when laying out the calculation, and then we just multiply. 2 times 9 is 18, 5 times 9 is 45, plus 1 is 46, and 7 times 9 is 63, plus the 4 is 67. So our answer is 6,768. For this question, you might use a short division method. So you might put 640 in a bus stop divided by 8, or you might recognise, you might be able to use known facts. You might recognise that there's a 64 and an 8 here. Now 64 is divided by 8 is 8. It's the square number. So therefore 640, which is 10 times bigger than 64, divided by 8, is going to have an answer that is 10 times bigger. So for this one, you may simply be able to do it mentally. If you know that 64 divided by 8 is 8, then you should know that 640 divided by 8 is 80. However, you may want to use a bus stop method, which you absolutely can do. 8 into 6 doesn't go, you're going to carry your 6 over. 8 into 64 goes 80 times, nothing, no remainders, and 8 into 0 goes no times. You can see both ways gives your answer of 80. However, this first method is quicker, and speed is also important in answering questions in the arithmetic paper. Here's a problem that throws some people because the answer is before the calculation. However, this is exactly the same as if we were to say 357 take away 89 equals, and then there's your box, there's your answer box there. So it's just a simple subtraction. You're just going to lay it out as you would any other subtraction. 7 subtract 9 we can't do, so we're going to have to take from this 5, that becomes a 4, that becomes a 17. 17 take away 9 is 8. We can't do 4 take away 8, so we're going to have to take from this 3. 14 take away 8 is 6, and 2 subtract nothing is 2. So the answer is 268. This is saying that 268 is the same as 357 take away 89. Here we have a simple short division. It is a short division because we are expected to know your 3 times tables in your head. So the divisor is 3, you're expected to know all your 3 times table facts. 3 into 5. Now 3 only fits into 5 once. 1 times 3 is 3, so there's a remainder of 2. 3 into 26 goes 8 times. 8 times 3 is 24, there is a remainder of 2. 3 into 21 goes 7 times. The answer is 187. You may have used a long division method to carry out this problem. You would do it exactly the same way. 3 goes into 5 once. We do 3 times 1 and subtract it, it's 2. Bring the 6 down. 3 into 26 goes 8 times. 3 times 8 is 24. We subtract it. We have 2. Bring the final digit down. 3 into 21 goes in 7 times. 3 times 7 is 21. We subtract it, we see we have 0, and we have solved our problem. Here we have multiplying fractions problem. The beauty of multiplying fractions is that we don't need to do any changing of the denominators. we can simply multiply the top and multiply the bottom. 4 times 1 is 4, and 6 times 8 is 48. So 4 48s is our answer. We can simplify this because 48 and 4 are both multiples of 4. So we can simplify this to 1 over 12. So for this question, we could use a short division method and use the bus stop, but actually we should be looking at known facts. So I know that 63, I'm recognising 63 is a multiple of 7. 63 divided by 7 is 9. Therefore, 630, which is 10 times bigger, is going to have an answer that is 10 times bigger. So the answer box is on the left, but it's just the same as if we wrote it the other way round. This is just saying that 90 is the same as 630 divided by 7. This question is about place value. It is partitioning this number. So here we have 6 million, that is representing this 6. And then we have our 70, which is 7 tens, which is representing this number 7 here. So the only digit that we have missing is the number 2, this 2 here. And this 2 here is representing, so we've got 1, 10, 100, 1,000 is representing 10,000s. So 20,000 that is. So we would write in 20 separator, 1,000. If we were to imagine these as arrow cards and we stack them all on top of each other, the 6 million, the 20,000 and the 70, we would end up with this number here. For this question, you don't need to be doing any kind of fancy long multiplication methods. You simply need to understand what happens when you multiply or divide any number by 10, 100 and 1,000. When you are multiplying by 1,000, the number is getting bigger. If it's a power of 10, 1,000 is 10 to the power of 3. So we're going to move each digit in the 2,671 is going to increase 3 places to the left. So if you imagined your hundreds chart, hundreds, tens, ones chart, that place value chart, each digit is going to move 3 spaces to the left. It's going to get 3 times bigger. So your 2,000 will become 200,000. In fact, I'm just going to start writing it in. The digits, when you're multiplying by 10, 100 and 1,000 or dividing, the digits always stay together. So this 2671 is going to stay together. Let me show you by writing 2671. Each digit is going to increase by 3. So the 2,000 at the moment is going to go at 20,000, 200,000, 2 million. So it's going to go there. The 600 is going to become 6,000, 60,000, 600,000. The 70 will become 700, 7,000, 70,000. The 1 will become 10, 100, 1,000. And if you think 1 times 1,000 is 1,000, right? So that becomes 1,000. I'm going to put my separator in, and then we use placeholders. Now we also need to put a separator there because our digits always come in groups of 3. So we can see the final answer is 2,671,000. Each digit from the original number has just increased in value by 3 spaces. Let me write that in a bit neater. 2,671,000. Here we have a simple adding fractions question. We can see that the denominators are not the same, therefore we cannot add them in their current form. Lots of you will have methods where you multiply the denominators by each other to get a common denominator. However, the first thing I always do is to check the denominators, to check if one of the denominators is in fact a multiple of the other. And I always like to look to see if the smaller number will fit into the larger number. So 3 is our smaller denominator. Does it fit into 12? Is it a factor of 12? Yes, it is, which means I can change this 1/3 so that it has a denominator of 12, and it means I don't need to do anything to my 5/12s. So I can in fact keep my 5/12s as it is. I'm just going to write out the question again on the squares. So we've got 5/12 plus 1/3, and you obviously don't need to rewrite the question out. You might want to, and that's absolutely fine too. I'm just going to show you that I'm going to keep this as 5/12 and add, and my 1/3 I'm going to change that to a fraction out of 12. 3 I've had to multiply 4 times. 3 times 4 makes 12, so I'm going to do the same to the top. If 3 times 4 is 12, 1 times 4 is 4. So 1/3 is equivalent to 4/12. It's just knowing your equivalent fractions. I haven't had to change my 5/12 as well. So some of you may have changed both of these fractions to 36. It would still get the right answer, but it isn't necessary. And the mark scheme changes all the time. Sometimes they want you to simplify the fraction, sometimes they don't. It's not always explicit. So just try and go with the smallest fraction if you can. So just check, does one of the denominators fit into the other? Now that we've got them both as 12s, we know that we can just simply add them. The denominator doesn't change, that stays the same. You just add in the 5 and the 4. Simple addition. 5 and 4 is 9. So our answer is 9/12. Now this, of course, could be simplified. And you know, I'm not sure whether or not the mark scheme would expect that from you or not. I would suspect that 9/12 is correct, is fine as it stands. Both of these are multiples of 3 though, so we can simplify this. We can divide both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4, 3/4. Now what I would say is, if you are confident with simplifying fractions, simplify it. Okay, just in case. If you are not so sure, it's better to leave it like that, because if you got this correct, the 9/12, but then you simplified it wrong, you would lose your mark. So simplify it if you know, you absolutely know you're accurate. If you're not sure on that simplifying bit, just leave this bit as it is. Okay, so for this adding fractions question, we can see that we have 2 different denominators, which means that we are unable to add them in their current form. What we need to find is a common denominator. So we need to find a common multiple of 3 and 5. So I can tell you that 15 is a common multiple of 3 and 5. So we're going to change both our fractions, our 2/3 and our 4/5. We're going to change them to fractions that have denominators of 15. These are equivalent fractions. We're not going to change the value of 2/3 or 4/5. We're just changing them to an equivalent fraction. Now, my 3 needs to multiply by 5 to get to 15. So I'm going to do the same to the numerator of 2. So that will be 10/15. Here, my 5 is going to multiply by 3 to get to 15. So my 4, my numerator, will multiply by 3 to get to 12. So we now have a new calculation, but you can see that we have common denominators now. So 10 plus 12 is 22, and the 15 just stays the same. Now 22/15 is our answer, but that is also an improper fraction because the numerator is larger than the denominator, so we need to change that to a mixed number, and that is 1 and 7/15. If you're unsure how to change from improper fractions to mixed numbers, I have lots of lessons on those in my fraction courses. Here we have the formal written method of long multiplication. I've actually added in the extra lines because that's how I like to do the long multiplication. So we're just going to make sure that when we first start, we're just multiplying everything by this 4. So 2 times 4 is 8. 1 times 4 is 4. 3 times 4 is 12, carry the 1. 6 times 4 is 24, plus the 1 is 25. We're now going to multiply everything by this 7. We need to make sure, by this 1, sorry, and that 1 is actually worth 10, so we put a placeholder in. So we do 2 times 1 is 2, and you can see it's actually 2 times 10 is 20. 1 times 1 is 1, 3 times 1 is 3, and 6 times 1 is 6. You can see the 6,312, you can see this is now 63,120 because it's being multiplied by 10. Once you've got your 2 lines in, you start to add these 2 rows here. 8 plus 0 is 8, 4 plus 2 is 6, 2 plus 1 is 3, 5 plus 3 is 8, 2 plus 6 is 8. Make sure with these questions that you continue your working out going down, you don't deviate and go to the side, because if you make an error you won't pick up a mark. With this, if I made one arithmetic error, I may pick up a mark depending on that year's mark schemes. But make sure your method goes down, you do your 2 rows and you add up your 2 rows underneath, not anywhere else on the page. So here is an order of operations question. For this question, you are expected to know that you need to carry out the 3 cubed first. So 3 cubed, 3 squared is 9, times another 3 is 27. So this question is simply asking you to do 2 plus 27, which is 29. There we go. Do not confuse this with 2 plus 3 is 5 and then cubing your 5. For this question, it's a division. We do not need to use a bus stop because you should know how to multiply and divide by 10, 100 and 1000 mentally. If you are dividing by 100, you are simply changing your number. It's just moving along 2 spaces. It's 2 zeros, it moves along 2 spaces. So there's your 15.5. Your number's going to get smaller, so your decimal point is going to moving. It's going to move 2 spaces, 1, 2. Okay, so your decimal point would be there, your digits stay together, and we can't leave this space empty, we put a 0 there, so it's at 0.155. Make sure your decimal points are clear, they don't look like commas. Here is another order of operations question. When we have a division, that is done before the subtraction. So we need to make sure that we solve this part of it first. So this question actually becomes 90 subtract 56 divided by 8 is 7. So the problem actually becomes 90 subtract 7, which is 83. Here we have a subtraction question that involves decimal numbers. The main thing that you need to watch out for here is making sure that you put the digits in the right places. So 6 in 63 is 6 tens, 3 and 63 is 3 ones. In our 5.8, we need to make sure the 5 goes underneath the 3 because they're both ones. And then we have our decimal point and 0.8. The next thing to make sure you do is when you're subtracting a decimal number, this number has 1 decimal, this number doesn't have any. I would make all your numbers have the same number of decimal places. So I would actually pop in a decimal place here and I would put a 0 here. That's not altering that number. So that we can subtract our 8 from our 0, because what a common mistake is people see nothing here and they just leave this as 8, when in fact 8 needs to be subtracted from 0, which we can now see we can't do, so we need to change our 3 to a 2 and make that a 10. So 10 subtract 8 is 2. I've seen that lots of times in the papers that people leave this answer as 8 because they've just seen nothing above the 8. So that's a 2. Then we do 2 subtract 5, which we can't do. So we're going to change that 6 to a 5, make that a 12. 12 take away 5 is 7, and 5 take away nothing is 5. So our final answer is 57.2. Okay, so we have a long multiplication. We need to make sure we set our long multiplications out correctly. Essentially, we're going to multiply everything by the 7 ones first, and then we're going to multiply everything by the 4 tens, and then we're going to add them up. So I'll be putting all my answers to 418 times 7 here. I'll be putting all my answers to 418 times 40 here. And then I'm going to add up my final answer at the bottom here. Okay, let's get started. So it's just knowing your times tables. 8 times 7 is 56. Remember to carry the 5. Some of you carry the 5 at the top, that's absolutely fine. Do it whatever way works for you. 1 times 7 is 7 plus the 5 is 12. 4 times 7 is 28 plus the 1 is 29. So now when we go to 8 times 4, it's actually 8 times 40. We're going to put a placeholder in. Always put a placeholder in first. In fact, you can even put the placeholder in before you've done any calculating, if you often forget to do that. So 8 times 4 is 32. 1 times 4 is 4. 4 times sorry, I didn't add the 3. 1 times 4 is 4. So 1 times 4 is 4, plus the 3 is 7, and 4 times 4 is 16. We now have all these to add up. You can see sometimes it is better to put your digits at the top because these sometimes get in the way. Obviously I'm writing on a digital tablet, so it's not as neat as if I was writing on paper. So now we're just going to add up all our digits. 6 plus 0, I'm actually going to do this in a different colour just so you can see. 6 plus 0 is 6, 2 plus 2 is 4, 9 plus 7, that's a 7, is 16, 2 plus 6 plus 1 is 9, and 1 plus nothing is 1. So our final answer is 19,646. Do make sure that you do all your working out going down, that you don't separate any of these and put them elsewhere on the page, because if you make an error you will not collect a mark for your working out. Here we have a subtraction with fractions problem. We can see that our denominators are not the same, so we can't subtract them in their current form. We need to find fractions with the same denominators. We need to find equivalent fractions. Now, what I always say to do first is to check the two denominators. Are they multiples or factors of each other? And I can see that yes, 7 and 21 both belong in the same times table. They both have a common factor of 7, but also that 7, the 21 is a multiple of 7, 7 is a factor of 21. Now what we would always do is change the smaller denominator to match the larger one, because we wouldn't be able to make this 21 a 7, we'd have to divide it by 3, and 11 doesn't divide by 3, but we can multiply any number by another number. So our 6/7, we're going to keep the 11 21s. So I'm just going to pop it over here, 11 over 21. The 6/7, actually if I write it out again, 6/7, and I'm just going to show you that the 21 is going to stay the same. The 7 I can change to a 21. I just multiply that by 3. So 6 will also multiply by 3, so that will become 18. So we've now got fractions with the same denominator, only had to change one of the fractions. So we know that our answer is going to stay 21 because the denominator doesn't change, and all we have to do is subtract 18, take away 11, which is 7. Now 7/21s is the answer, but we can see that they have actually got a common factor. We said this earlier on, 7 and 21, they're both in the 7 times table, so I can actually simplify this by dividing both parts by 7. 7 divided by 7 is 1, and 21 divided by 7 is 3. So my final answer is 1/3. Here we have a question with fractions dividing by number, one of my favourite types of problems. Now I always use the keep, change, flip method. We keep the first number, we change the division to a multiply, and we flip our 2. We use the inverse. The inverse of 2 is a half. We simply put the number that we have underneath a 1, we make it into a fraction, we put a 1 above it. And now that we have got a multiplication, multiplying fractions is really easy because you just multiply the top and you multiply the bottom. So we multiply 7 by 1, it's 7. We multiply 10 by 2, it's 20. 7/20ths, 7 and 20 don't have a common factor, we can't simplify it. Our final answer is 7/20. Here we have a question where we need to subtract a proper fraction from a mixed number. With questions like this, I always change my mixed numbers to improper fractions before I do any calculating. I do that with adding and subtracting. It is possible to do it without doing that, but there is a likelihood you'll be inaccurate. So If you're not sure how to change improper fractions and mixed numbers to each other, I've got lots of lessons on those in my fraction courses. So let's have a go. So 2 and 3/8, we're going to change that. They've got common denominators, so I don't need to do anything. They can stay as 8. So 2 times 8 is 16 plus 3 is 19. So my 2 and 3/8 is going to become 19/8. I'm subtracting, and the 5/8 can stay as it is, 5/8. You can see as soon as I've subtracted them, as our denominators are the same, I can just simply go ahead and calculate. I know that the answer is going to be 8, and then 19 take away 5 is 14. So my answer is 14/8. Now you can see that this is an improper fraction. It's top heavy, the numerator is bigger than the denominator, so I'm going to change this to a mixed number. So it's doing the opposite of what we did here, mixed number to improper fraction, now improper fraction to mixed number. This is 1 and a big 1 and 6/8, and the 6/8 can be simplified. 6/8 can be simplified to 3/4, so my final answer is 1 and 3/4. So here we have a question where we're multiplying a 2-digit number by a decimal number. Now there's a couple of ways you can think of this question. You could rewrite this question, rewrite the 0.7 to be 7/10 times 26, which is the same as 7/10 of 26. And if you know how to find fractions of numbers, you divide by the denominator, then times by the numerator. Or you can use known facts, which is what I am going to do. So I'm just going to write 0.7 times 26, and underneath I'm going to write 7 times 26. Because the 0.7 relates to the 7. 7 is 10 times bigger than 0.7, and I can see that this calculation is fairly easy to do, 26 times 7. So we're going to do a short multiplication, 26 times 7. And so we're going to do 6 times 7, just going to change the pen colour to make it a bit clearer. 6 times 7 is 42. 2 times 7 is 14, plus the 4 is 18. So if we know that 7 times 26 is 182, 7 is 10 times bigger than 0.7, so the answer to this question at the top is going to be 10 times smaller. And to divide 182 by 10, I simply just move my decimal point along one place. So this is 18.2. If you're not sure how to multiply and divide numbers by 10, 100 and 1,000, I have got lots of lessons available on that topic. Here is a long division question. You need to be shown the correct method of long division to get any kind of marks in a question like this. If you are unsure of long division, I've got lots of lessons on them. I've got them in my number calculation book, but I've also got a long division course. If it's just long division, it's a really good course that breaks down all the steps and makes it really simple. So we are dividing by 34. The first thing I would do is I would write out my 34 times tables, and I would list them down the side. So I've listed my 34 times tables. You don't ever need the 10th one, but I like to put it in because it helps to see if I've made any mistakes elsewhere. And now we can simply start to divide. So 34 does not go into 9. I'm going to put a 0 there. Some people bring the 9 down here. I keep it here. Now I'm looking at 98. 34 into 98. I can go down my times tables. I can see it's only going to fit in 2 times. And then I write down what 2 times 34 is, it's 68, and I write that underneath, 68. I'm now subtracting 68 from 98. 8 take away 8 is nothing. 9 take away 6 is 3. And I bring this digit down, I've now got 306. And I go down my times tables, and I can see it fits in 9 times. I write 9 at the top, and I just might want to prove it. 9 times 34 is 306, write it underneath, subtract it. Well, 306, take away 306 is going to be 0, isn't it? If you've ended up with 0, you've got your final answer. And that's my answer, it's 29. But writing out these times tables makes it all so much quicker. So for a question like this, there are lots of different ways you can do it. I've got lots of lessons on calculating percentages. You could do 600 times 99 and then divide that answer by 100. You could break down your 99%, so you could find 50%, then 40%, then 5% and 4%, sorry. That would be fairly simple to do. That gives you your 99%. However, I'm going to find, as it's so close to 100%, I'm going to find 1% of 600. So 1% of 600, I'm just going to be dividing by 100. 1% of 600 is 6. I could do that really simply in my head. So if 1% of 600 is 6, 99% of 600 is going to be the 600 subtract the 6. So now all I need to do is 600 take away that 6, and I can do that in my head as well. It's 594. So much easier way to do it is it's about efficiency, not just knowing the skills. So if it's very, very close to 100%, think about finding the smaller part, the bit, you know, the supplement to 100, and then you can just subtract it. Here we have another one of my faves, dividing with fractions. Keep, change, flip is what I use to remember what to do. We keep the fraction, keep the first number, we change the second symbol, we change it from a division to a multiply, and we flip the 3. We put the 3 underneath a 1. The opposite of 3, or the inverse of 3, is 1/3. We now have a multiplying fractions question, and when we multiply fractions, we simply multiply the numerator and multiply the denominator. We don't need to change a thing. 1 times 1 is 1, and 2 times 3 is 6. It's already in its simplest form. The final answer is 1/6. So to find 43% of 900, I'm going to do some partitioning, and all I need to know to help me find this answer is 10% and 1%. So 10% and 1%. 10% of 900 is 90, and 1% of 900 is 9. And that's going to help me to find the 40% and 3%. To find 40%, I just need to have 4 lots of this 90, so 90 times 4. I know that 9 times 4 is 36, so 9 times 40 is 360. To find 3%, I just need to find 3 lots of this 9, so 9 times 3 is 27. So I've got my 40%, I've got my 3%, I just need to add those, and I can actually add them right there. 0 plus 7 is 7, 6 plus 2 is 8, and 3 plus nothing is 3. So my answer is 387. So here we have our second calculation where we are subtracting a proper fraction from a mixed number. So we need to change, as we did for the other question, our mixed number to an improper fraction. But please also notice that these denominators are different. So we're also going to have to change some denominators as well. I like to always first check if these two denominators are multiples or factors of each other, and in fact they are. 6 and 3 are both in the same times table, and I like to change the smaller denominator to match the larger denominator. So I'm going to be changing this 3 to a 6. So I'm going to do 2 separate things. First of all, let's change this mixed number to an improper fraction. So 2 and 1 6, 2 times 6 is 12, plus 1 is 13. So the 2 and 1 6 is going to become 13 6. So we're going to be doing 13 6, subtract 2/3, and we can't do this yet because our 2/3 has a different denominator. So I want to change this third to a 6. So I'm going to write it out again. So I'm going to be doing 13 6, subtract, and then this 2/3 is going to be, find the equivalent fraction where the denominator is 6. The 3 I'd have to multiply by 2, so the 2 I multiply by 2. So that becomes 4 6. And we can now subtract that because it has the same denominator. We're just going to look at the numerators. 13 subtract 4 is 9, and then the numerator stays as 6. we've now got a improper fraction, and we can change that to 1 and 3/6, and then we can see this 3/6 can be simplified. 3/6 is the same as a half, so our final answer is 1 and a half. 1 and a half. Make sure you can see that 2 there at the bottom. Always make sure when you're writing your answers that the answers are very, very clear. They can't be mistaken for another answer. So I've just rewritten that so you can definitely see the 1 and a half. When we have a mixed number multiplied by a number, I like to partition. So I would partition this 1 1/4 into its whole number, and then I would separate that from its fraction, and then I would multiply it separately. So I would be doing 1 times 39, which is 39, and then 1/4 times 39. Now 1/4 times 39 is the same as 1/4 of 39. To find 1/4 of 39, you can either divide it by 4 in a bus stop, like that, or you can halve and halve again. I'm just going to use this bus stop, so 4 into 3 doesn't go, I'm going to carry it over. 4 into 39, it goes 9 times, that is 36, so there is a remainder of 3. We are going to put a decimal point here and a decimal point here, a 0, and carry on our remainder here. 4 into 30 goes 7 times. 4 times 7 is 28, so that's going to have a remainder of 2. Put another 0 in, carry on my remainder. 4 into 20 is 5, so it's 9.75. I'm just going to put that down here. If you had done it the other way, half of 39, so 39 is very close to 40, half of 40 would be 20, so half of 39 is 19.5, and then if you half your 19 and a half, you could halve that in stages. The other way to do it would have been to halve and then halve again. So if you think of your 39 as 30 plus 9, and you halved your 30 is 15, half your 9 is 4.5, that's 19.5. So your 19.5, we can think of it as a 10 and as a 9 and as a 0.5. Half of your 10 is 5, half of your 9 is 4.5, and half of your half is 1/4, 0.25. If you add up those 3 digits, 5 plus 4.5 plus 1/4, 5 plus 4.5 is 9.5, 9.5 plus 0.25 is 9.75, sorry. So either way, you get to the same answer. One method though requires you knowing how to divide with remainders that can be converted to decimals. Okay, so we have our second long division question. We are dividing by 73. No one's expecting you to know your 73 times tables off by heart, so you always start by writing out your 73 times tables. So I've written out my 73 times tables, labelled them 1 to 10. I know that I don't ever need to use my 10th one, but I use that to make sure I haven't made a mistake here. So 73 into 4 isn't going to go. 73 into 42 isn't going to go. So the first number we're looking at is this 423. We look down our list, we can see we can only go as far as 5. So I write 5 at the top, and then I write that number, that fifth multiple, 365 underneath the 423, and I subtract it. I can't subtract 5 from 3, so I need to make that 2 a 1, and that make that 13. So 13 take away 5 is 8. Can't do 1 take away 6, so that becomes a 3, that becomes an 11. 11 take away 6 is 5, 3 take away 3 is nothing. So 58, and we bring down this next digit, 584, go down our list, and we can see 8 times. We write down the answer to 8, always write down the answer underneath and subtract it. 584, take away 584, we know is going to be 0. We have found our final answer with no remainders. Very easy to do once you've listed your multiples. The most difficult part is the listing of the multiples. I hope that you found this video useful. If you are looking for any more support for your maths SATs in 2026, then check out pocketprivatetutor.co.uk, where I have loads of things that could help you.